Hi, welcome back to my IPv6 series of sessions. Here I am going to explain some basic fundamental IP version 6 like how to explain, how to configure dual stack, 6 to 4 tunnel, ACL, SSH. So I'm Kundan from technical team of networkers. So let's start the session. Dual stack, why we require dual stack under IP version 6? The major requirement of dual stack, IP version 6 addresses could not assigned as router ID. The first purpose is that without router ID, dynamic protocol, EIGRP, or SPIA border gateway protocol, ISS, they couldn't start their functionality for that. So dual stack nodes, actually both IPv5 stacks are enabled on one router's interface. We have the option to assign IPv4 as well as IPv6 addresses. Application can talk to both choice of IP version based on the name loopback, lookup, and application preference. And what is dual stack operation? An application that is not aware of IPv6 or is forcing the use of IPv4 asks the DNS for IPv4 address, connect to the IPv4 address. So it's also option if that doesn't going to understand the IPv6, in case IPv4 addresses can use for that. And in case of IP version 6, an application that is only IPv6 enabled or has the use of IPv6 because it is the only stack or enforcing the use of IPv6, ask the DNS for IPv6 address, connects to the IPv6 address. And in a dual stack case, an IPv4 and IPv6 enable application asks the DNS for all types of addresses. Option chooses one address, connect, for example, to the IPv6 address. It depends upon what's our requirement. And here it is the IPv6 unicast routing to enable IPv6 address, enable IPv6 manually on router, and then you can say interface Ethernet 0 having IPv4 as well as IPv6 address. And so if IPv4 and IPv6 addresses are configured on an interface, the interface is dual stack enabled. And now we have the option, suppose end-to-end, we have IPv6 network, in between we have IPv4 network, the use of the tunnel mechanism, end-to-end IPv6 network can communicate. So actually tunneling is encapsulating the IPv6 packet in IPv4 packet so that we can bypass entire IPv4 network and end-to-end IPv6 communication can execute properly. So we have the option, tunneling can be used for routers and hosts, depend upon for what purpose you want to use. And then we have the IPv4 header, IPv6 header, IPv6 data. So many techniques are available for establishing a tunnel. Manually, we can configure semi-automatic tunnel broker, automatic, compatible to IPv4 624. Also, we have the option 4 to 6 tunnel. In 624 tunnel, end-to-end, we have IPv6. In between, we have IP version 4. So tunnel source and destination remains IP version 4. Tunnel addresses remain IP version 6. This is called 624 tunnel. In the reverse, also we can execute end-to-end, we have IP version 4. And between we have IPv6, so same mechanism we have. Tunnel source destination will be IP version 6 and tunnel source will be IP version 4. To execute this tunnel part, what the requirement is, dual stack endpoints, we require both IPv4 IP addresses configured at each end. And here you can see interface tunnel 0. Actually, tunnel address is IP version 6. End-to-end, we have the IP version 6 network. Hosts are in the IP version 6, the router part interface towards host. That we have IP version 6. And between router 1 and 2 interfaces, we have IP version 4. So both router, when we have proper reachability, actually they are connected directly. So interface tunnel, what the number we want to use. And tunnel address is IP version 6. Tunnel source destination IP version 4 and tunnel mode IPv6 IP. So both end we will configure this thing, end-to-end communication will start. And IPv4 compatible addresses are an easy way to auto tunnel between dual stack, but they are unlimited, they do not scale, they are deprecated. So this thing we need to remember. And 624, it is an automatic tunnel method, gives a prefix to be attached IPv6 network. So IPv6 address the destination, IPv6 destination, and then in between we have IPv4, so IPv6, IPv6, IPv4, and IPv6 part of the mid part, it shows that tunnel address is IPv6, source and destination is IP version 6. The same method we have mentioned here. Also, we have the option here that IPv6 unnumbered Ethernet 0, Ethernet 0, IPv6 unnumbered Ethernet 0, it will fetch that thing from there, tunnel source loopback, and tunnel mode IPv6, IP624, and then we need to provide the default route pointing to the tunnel. So that is possible. So here we have the 2002, we have used there, and rest of the part, and 16. So we have to do the summarization aggregation there. So this is another method we can use also. And 624 relay, it is a gateway to the rest of the IPv6 internet. It is a default router. We have already explained this thing. Here you can see this thing, IPv6 route. And then both options, we have the default part that we have mentioned earlier in the previous slide. And tunnel broker, configure the tunnel on the tunnel server or router, tunnel information sent via HTTP IPv4. So website sends request to IPv4, tunnel information response to sent an IPv4 tunnel broker. Then we have the client establish the tunnel with the tunnel server or router. And tunnel server represents a simpler model. Server is both for the web request or for the tunnel endpoint. This purpose we are using tunnel server. Another method we have ISATAP provides intra-site automatic tunnels and global routability for ISATAP IPv6 host. And these are the options we have manually configured. Stable always on link used to interconnect sites, IPv4 compatible, automatic tunnel representative 624, automatic tunnel CADR 48 IPv prefix form using IPv4 address used by the end site, tunnel broker and tunnel server, semi-automatic tunnel, allocate IPv6 addresses or prefixes to end users or sites, and ISATAP, automatic tunnel, intra-site mechanism for sparse and enterprise IPv6 deployment. Another transition mechanism is Trado is a NAT-aware transition mechanism that allows IPv4 and IPv6 dual stack nodes behind a NAT device to obtain a globally routable IPv6 address. The Trado mechanism relies on Trado server and relays, which are internet-based, to obtain an IPv6 address prefix and service. And how Cisco IS supports IPv6 telnet. This is the Cisco router will by default listen to IPv6 interface address on port 23 just as they would for IPv4. There is no changes. And then telnet use the IPv6 address. And rest what option first we need to enable telnet on router. That mechanism remains the same. Same for SSH support. Cisco IS software support IPv6 SSH. Secure cell can replace telnet for intra-site session on router for added security. Authentication is protected. Session is protected because in telnet, all information what we want to share endpoint remotely, that remains in plain text. Here it is authentication, authenticated and properly encrypted form. SSH is available in Cisco software with the 3-dash cryptographic software. And once we have enabled the SSH, these are the options: login, what all option, dash, triple dash. Every of this way we can take the remote login through SSH. Connect to SSH server specified on IPv6 address or a host name. And Cisco IS support software support IPv6 SSH server and supported on platform using Cisco IS 3-dash software. IP SSH, what time out in second authentication, and then to verify through IP SSH and through SSH. Through IP SSH displays the version and configuration data for SSH, and through SSH displays the status of HSS server connection. And these IPv6 applications available in Cisco IS software for network diagnostics. These are traceroute, ping, and HTTP. And Cisco IS IPv6 DFTP support now support transfer over IPv6 So copy running config TFTP, then what the addresses we have, and running config mode. So we can enable execute TFTP utility. And right now ping supports both IPv4, IPv6. It's optional. You want to use IPv6 ping. Otherwise, ping and IPv6 address can execute it. On this is not longer required. I ping IPv6 directly. It supports both IPv4, IPv6. And IPv6 HTTP support. Enable IP HTTP. Cisco router will by default listen to IPv6 interface addresses on port 80 just as they would for IPv4. IPv4 HTTP access class mechanisms do not work with IPv6 ACL. And Cisco discovery protocol to verify the physical connectivity used to discover protocol address and platform information of neighboring devices runs on all Cisco devices, routers, switches, and so on. And CDP IPv6 support adds IPv6 address and address type information. Same mechanism we have. So CDP entry we can use, and so CDP neighbor, type detail, CDP entry like device name, version, protocol, all this information we have. And so CDP neighbor detail you can find device ID, router, and entry addresses, IPv6 addresses, platform, 2620 capability, router switch, interface, fast Ethernet, port ID, outgoing port, all information we have as we are getting in IP version 4. And Cisco Express Forwarding similarities between Cisco Express Forwarding v6 and v4, rapid packet forwarding on interface, behavior of commands. So IPv6F we want, we can enable IPv6F distributed, enable distributed step mode 7600 GSR gigabit switch router, 75 gig router. The IPsec distributed command must be enabled first. On 7500 on GSR router, IPv6 step distributed required. And IPv6 accounting per prefix length, configure per prefix or prefix length accounting, depend upon our choice. And these are the show command we can use. So IPv6F, that is prefix detail, interface detail, so IPv6 adjacencies, so IPv6F non-recursive, so IPv6F summary, so IPv6F traffic prefix length, so IPv6F unresolved. All these options we have to verify. And so command of both step v6 and v4, so step drop, so step interface detail, so step line card, so step not step switch. So this command we can both execute for IPv6, step IP version 6 and as for IP version. And the debug command for step IPv6 debug, IPv6 step drops, event has received and step table. This command we can execute to verify all the details. And Cisco IS standard access control list, when used for traffic filtering, IPv6 ACLs perform the following functions. Filter traffic based on source and destination addresses, filter traffic inbound or outbound to a specific interface, include an implicit deny all at the end of the access list. So we have the option IPv6 access list, what the name we want to use, and then which traffic we want to apply, access list, block, permit any, we deny after that permit. We doesn't have name number utility, IPv6 access list, standard extended, both option we have. And on interface in IP version 4, it was IP access group. Here we have IPv6 traffic filter. And IPv6 extended ACLs features similar filtering features as IPv4, IP address, traffic class, upper layer protocols, and new IPv6 features, flow label, extension header, ICMPv6. This is the new features we have. That features is not available. For that completely we have to enable class bit weighted fear queue. Here we can apply all these extensions used for traffic filtering only to filter routing protocol prefix, use IPv6 prefixes. And extra other features, implicit I rules under each ACL, permit ICMP any, neighbor discovery for the neighbor solicitation, neighbor advisement, deny IPv6 any. And reflexive and time-based ACLs, IPv6 support for reflexive and time-based ACLs. Behavior in IPv6 is identical to IP before extended ACLs. Reflexive access lists create temporary entries matching an allowed session. Time-based access lists define a time range when an entry is valid. When the entry is valid. The following optional keyword available in IPv6 extended ACL. This is the extra features we have. Differentiated service port point value matches value against the traffic class field. Flow label we can decide. Routing match the preference of routing extension header. This is the new features we have in IP version 6. Also we have the fragments match the presence of initial fragment, extension header, undetermined transport matches missing or undetermined transport layer for information. And some filtering features IPv4 as with the new ICMPv6 type. Actually, IPv6 doesn't use the ARP resolution. In place of ARP, it uses never advertisement, never solicitation, router advertisement, return solicitation message. So these options we have in IP version ICMPv6 type. And then IPv6 access list name and what the permit deny, source prefix, any host address, and then we have the range, destination prefix, DSCP value, flow label, fragments, routing, reflexive ACL name, timeout, time range. So lots of options we have here. And Cisco ISIP extensor ACL interface command, reflexive ACL, IPv6 traffic filter name in out, the filtered incoming or outgoing traffic according to the specific access list, what direction, what we require. Here you have the option that IPv6 access list filter, what the permit thing, TCP, UDP, and then interface IPv6 traffic filter in. In the receiving direction, we are going to apply in the fast Ethernet 00 interface. And same features we have here. And filter outgoing traffic using reflexive ACL. So here what we required IPv6 access list, we have given name outbound. Then the traffic reflect out, deny what the traffic we want to use. And then IPv6 access list inbound, commit ICMP any, evaluate, reflect out, deny ICMP log and interface, traffic filter outbound or traffic filter inbound. So this way we can configure reflexive ACL under IP version 6. And the filter outgoing traffic, same option we have. As I mentioned earlier, all the command syntax here. And these are the show commands we can execute. So clear and debug command, show IPv6 access list, clear IPv6 access list. Instead of no IPv6 clear, we can remove the entry, debug IPv6 packet, access list, ACL name, optional keyword. If you want IP access log update threshold, all these things we have. So thanks for this session. Next time we will define another extra features of IP version 6.